So one solution could be you can try to learn this kind of curve. Okay, so I mean, as I said, it's not impossible, you can do that. But then the issue will be, then you're kind of trying to overfit to this training data. Okay, so what might happen, let's say you learn this curve, then what if your testing sample is actually at this point and all your testing samples are at this location? I mean, your classifier will completely fail, right? Because all those testing samples will be on the wrong side of the boundary. Okay, so that's what is the limitation of your support vector classifier. And that's just one scenario where the boundary is not linear. The other interesting case is, what if they are not even connected? Right? For example, you could have a data set which is something like this. If you look at the distribution, and the blue dots over here and the blue dots over here, they actually belong to the same category. But in the embedding space, they are actually far away. Right? So in between, you have this purple class. Now, I mean, how hard you try, I mean, you can for sure not create a decision boundary which is linear and use that as a classifier to solve the classification problem on this kind of data. Okay, so if you try to learn, let's say, a support vector classifier using this training data, you might get something like this. But again, it might work for some samples. Let's say your accuracy could be, let's say, what, 40%, 50%, depending upon how many of these samples are actually falling in this side. And so all these purple ones are correct and all these blue ones are correct. But then you might have a lot of purples here as well and a lot of blues here as well. So you might get, let's say, 40%, 50%, but it can never go beyond that. Okay, because it doesn't have that capability to separate this kind of space. So now, if you think about this, one easy solution could be, if your decision boundary looks like a circle, okay, then that seems like a very good classifier for this kind of data. And then you can say that whenever a sample is inside that circle, it's like purple. Outside the circle, it's blue. Okay, so let's see see how we can do that. And that will lead us to nonlinear SVM, and that's also called support vector machine.